Alright, so in this podcast we're talking about types of redox reactions. And redox is kind of the topic of this unit. And it's simply the transfer of electrons between one substance, usually an element or compound, and another element or compound. So redox is short for reduction and oxidation. We just combine it together and just call it redox. So there's basically four types of redox reactions, and I'm kind of going to define them, and then we'll have some examples, and but be able to recognize them, identify what type of redox each is. So the first one is called combination, and fancy books call this synthesis. So we're going to call it combination / synthesis. And this is type 1, and it's simply if we have some compound or some element plus another element, and they combine together to make a bigger compound. The second type is called decomposition, and it's basically the reverse of combination or synthesis. And I'm just realizing I forgot a letter up here in synthesis. There should be an H right there. Synthesis. The second one is decomposition, and it's simply we start with a big molecule, we're just going to call it AB, and it breaks up into A plus B. So A right here could be an element or a compound. This could be an element or a compound. Typically it's two elements that make a bigger compound. Similarly down here this could be a really big compound that splits into two compounds. More likely it's something that splits into two elements. Our next one is called single displacement. This is just type 3. And single displacement is simply where one thing displaces something else, or takes the place of. So in this one, we typically have A plus BC yields possibly B plus AC. Alright, and the way to know this one is it always starts with an element and a compound. We always end with an element and a compound. And there's a couple things that can replace. It's either metals, replacing metals. Sometimes it is hydrogen replacing a metal, and at other times it's a halogen replacing another halogen. So those are the three types of single displacements that we can have. But again, just the category is known as single displacement. And our last type of redox is known as combustion. And this one we'll talk a lot about in our unit on kind of organic chemistry, because whenever we burn oils or gases or natural gas, we combust it. And combustion simply means reacting with oxygen, but generally speaking we have what's called a hydrocarbon, so something that consists of hydrogen and carbons, and some number of them. The number doesn't matter, but when we react it with oxygen, we always get these two products, carbon dioxide and water. And depending over here on what X and Y are, it will depend on how we balance the equation. But hydrocarbons plus oxygen yield carbon dioxide and water. So we're just going to go from the bottom back as far as examples go. So CH4 is known as methane. If we react methane with oxygen, this is no surprise, we get carbon dioxide and water. Alright, something kind of like that. Our next one, let's say we react zinc with sulfuric, or we'll just do it hydrochloric acid. So what happens here is really in hydrochloric acid we have a cation, which has a positive charge, and an anion, which has a negative charge. Okay? So depending on what zinc is and what charge is zinc, well, it's a metal. So when it's an ion, it always has a positive charge. So what it's going to do is it's going to replace the hydrogen. So over here on this side, we're going to have zinc, and now it's with chlorine, so we're going to call that zinc chloride. And remember that zinc is always a +2, chloride is always a -1, so they're in a 1:2 ratio, so we have to put a 2 here as a subscript. And then we also get hydrogen, and it's now by itself. But we're not going to write hydrogen like that. It's one of our diatomic molecules, so it gets written H2. And for now, balancing was a first semester thing, so all we're doing is predicting products. If I wanted you to balance it, we could balance this with a 2. Down here, so I didn't even balance it, so that is not as important here. What's important here is predicting what's going to happen, and really recognizing that this equation is a single displacement equation. Our next one, let's do this. We'll do KClO3. And this was a lab we did back in first semester. When we heat this, it decomposes, and we get potassium chloride and oxygen gas. When we did this lab, this was a white crystal, and it kind of got all puffy, kind of like styrofoam, and the oxygen just became part of our atmosphere. So we weighed this, and we weighed this, and we were able to determine the percent composition of potassium chlorate. So notice we started with one big compound, and we ended with two smaller compounds. All right? And then our last one's going to be hydrogen plus oxygen. And when we react hydrogen and oxygen, we get water. So notice we start with two elements, and we ended with a compound, so they combined together to make one big thing. So anyways, no types of redox reactions. Combination, decomposition, they are opposites of each other. Single displacement, where something displaces or replaces something else in a compound. It's always an element with a compound, and our products are element compound. And then the last one's combustion, anything reacting with oxygen. What I want you to know is hydrocarbons reacting with oxygen, and they always get carbon dioxide and water.